Now, this is a df over dx, correct? What does the d mean? The d means it is a total derivative of the function. Now, what if your function is not only depending on x, but it also depends on y and z? What will happen to that? So let's say your function, pick a function, j. What if the function j is actually depends on x, y, and z? Then how will this equation that I'm giving with a star change? Well, now I can't write d over dx. What do I have to now write? I have to write partials. I have to write how much j depends on x plus how much j depends on y plus how much j depends on z. And since this is a vector quantity, what do I have to do to make this a vector? Give it directions. How do I give directions to any equation? I hat, j hat, k hat. Okay, so I'm going to add I hat, j hat, k hat. And notice I am using partials here because this function j depends on x, y, and z. So I can't take full derivatives with respect to each one. I have to take partial derivatives. And that is a point that people get confused at. Don't get confused at it. All it is you're doing the same thing mathematically, nothing changes, but one time you are differentiating it with respect to x, one time with y, and one time with z, and you're just adding I, j, and k on top of it. Done. Okay, that makes it partial derivatives. And the function, it's really hard to write partial x over partial x, partial over partial y, and so on. So we have summarized it in a operator that we call the del operator. And the del operator is defined as partial over partial x, partial over partial y, partial over partial z. That's all there is. Do you see the progression? So if the function that's given to you is only a function of one variable, you can take the full derivative of it. If it depends on anything else, then you have to take partial derivatives. Mathematically, it stays the same, but you should fundamentally understand why you're taking full derivatives versus partial derivatives.